Okay. So let me share my screen. I'll just show you this little bit I learned in multi-label classification. I've been focusing in on that, and there's actually a library called Multi-Learn, and it's a sort of like built on sklearn, but I really don't understand most of it, a lot of it, and it's definitely not text classification centric, that's for sure. But I'm beginning to learn a little bit of it, and I'll show something I used. So let me see here. There we go, in Colab. Okay, so this is a simple transformers baseline, where out of my 4,000 topics in our IT taxonomy, I just take 10 of them, each with 500 documents. And by the way, it performs really good when it's that simple, right? And it does, like, I get like 98% accuracy and, almost 90% recall, which is pretty damn good, right? But my problem is I have to build up to a really multi-label problem. And so thank God I finally got this base working really well, though. But as part of that, when you split your sets, right, scikit-learn has a stratify. I don't know if you guys are familiar with that, but the stratify is so it'll split your training and test set and balance out the actual classes that are in each. So you don't, so you're training with examples for every class or topic, and then you're also testing on those. However, when it gets to multi-label classification, it can get quite difficult and complicated to do that. And you end up with, some classes not represented or overrepresented or underrepresented. And I don't understand all the details of that. But and also with this 10 topics, it doesn't show it very clearly. But I use this library right here. It's called SK Multi-Learn. Okay, or it's also called scikit-multi-learn. And they have this stratify process. There's a video on it that explains it, and they call it, it's a tags, an iterative, it stratifies iteratively using tag sets. And what a tag set is, two or more tags together. So it not only tries to distribute the individual topics, but as you're distributing examples for individual topics, right, because it's multi-label, you're also inadvertently distributing other topics. So somehow it makes sure that all works out well. I don't think it's about the co-information or whatever between the topics that are on in a tag set, but it's just to help you distribute your set more properly. And when you do it, it's, it looks just like sklearn. So here, there you go, right? One trick to it, though, which screwed me up, is that usually when you do this split, right, like I'm using like with simple transformers, I have the text. I have data frames with text. That's what simple transformers uses. But the problem with having the text of the document is the NumPy arrays memory just dies. I mean, you just blow out your memory, and your Colab or whatever you're using is going to die because you can't, because NumPy array is not made. It's made for numbers, right? So what I did to get around that was I just used the IDs for each document, and then I stratified, and then I just joined back in the full text, because you need that for transformers, right? It takes full text. You input it, and so I did that, and of course then it means you have to double check the hell out of your stuff to make sure you didn't discombobulate everything. But that was one little interesting hurdle I had to get around. And then they have this where they show you your distribution. So you see this table, data frame here. They're just showing you across the train and the test set how many example documents you have. Now you see this tag set. The funny thing is I have so few tags, but this tag set is a 6 and a 6, right? So that's topic number 6 and topic number 6, right? So this is just a tag set of 1, right? So, but over here you start seeing where this has tag number 2. I don't remember what topics they are, but and topic number 4. And you could see that the training set got 1 and the test got 0. So that's not too good, right? But it's just because my data is so sparse now because I've reduced it. But you can see here it took a 0 and a 2 and it split it across nice and evenly. So you can use this to see how it distributed your tag sets. Now, does that make some sense? Although I didn't really describe the logic of the iterative tag set distribution, but it gives you a better. So much of data science and machine learning is about data distribution, right? It's like 90% of the game, and so this is supposedly gives you better data distribution for your training and testing. So, any questions about that or thoughts?
I don't think I fully understood, but maybe I will read it up. It's probably
Yeah.
It's
exactly.
Interesting. Yeah, I mean, what it is.
Yeah, I think you'd be quite interested in the video. Let me just see if I can find it real quick. Where he describes it, 20-minute video or something.
Oh, okay.
ML, what is it?
Multi-learn.
Yeah. Maybe I'll be able to see which one. Yeah, there must be this one. Yeah, that's the one. Yeah.
Right.
So, but anyway, I did think you'd probably be kind of interested in that. Okay. Yeah, I don't think I can offer much of an explanation. And just to take a quick look at some of the, there's training it. That's nothing. That's just the parameters. And oh, there you go. So I do this. I have to do a funny thing, right? Because you want to find out what the optimal threshold is, right? So I have the model, and I test on the model. I mean, I get the ranked results from the model, right? So you predict on your test set, and you get from the transformer model through simple transformers, and you get back both the binary because you're allowed to enter a threshold, but you can also get back the ranked results, and then I can use different thresholds. So here's the data frame where I just run through the results from the transformer, right? And here's threshold, 0.19 all the way up to 0.705. I don't know why I bounded it by that, but you could see here at a threshold of 0.705, which is that's a really high threshold, but I have a 0.987 precision and a 0.41 recall. But you can see here at 80% precision, I get 92% recall at a 0.2 threshold.
Right. You have a pretty large plateau as well, right? I mean, you can see, if you look at the graph below that, kind of indicates that, right? So you got a nice plateau all the way from
It's a nice shape, isn't it? I've seen a lot of shittier shapes than that one. That's if you think about like under the curve, or ROC or whatever. That's a big space under there, and it's really nice. So you'd probably want to pick something like that, depending on your business needs, right? Like at 0.9, because you're still getting 80% recall. That's ridiculous. But that's 10 topics. I mean, that's a wimpy classification problem nowadays, right? That's no big deal. But and then I do a classification report, so you could see, and I pick a threshold. So that's the point above. I'm picking a threshold, and I use that threshold. I'm not sure where I did that. Yeah, report threshold. Sorry, I'm kind of dragging this on a little bit, though. I'll try to wrap it up. But I pick a particular threshold. There's my report. I actually pick 0.19, and then I can just see for each topic, right? I don't totally understand the micro versus macro stuff all that well.
Macro is just the average of all the numbers, and micro takes the number of items in each of these things.
It weights. I get it. Yes. Right. So it's more like a document. It's more like a document point of view than a topic point of view in a sense. It helps weight it. Yeah.
In your case, it's almost all the same if you look at the support, right?
Yeah. But, which is a good thing, probably, right?
Yeah. Well, multi-learn has basically helped you do that, right? I think.
Yeah. And it probably means that I don't have a large. Here's a bad one right here. IT automation. And they all have the same number of documents too.
Right.
Well, they're all almost 550, right? Because it's a baseline. I didn't want to deal with imbalances either. So,
right.
Anyway, that's. I think that's my story, guys. That's all I have. If there's nothing else to add to that from you guys, I'll ask my question. I'll stop sharing.
So can I ask you really quickly? So just. Actually, I wanted to look at the code. So you're classifying documents, right? So I just I think I got distracted. I don't know if you in the middle. So you have documents and you have topics, and you split them, and then you run transformers on each of the document, and then do you have your own layer? How do you get the classification? Do you have a task?
I'll show you. I do it simply because I use simple transformers. Okay. So I don't have to deal with any tokenization, any layers. It's all there ready to be had. I'll show you though. It's interesting. I'm sure we've talked about simple transformers before. Let me share again. Let me share again, and I'll just show you that part of the code so you can get a real quick, intuitive understanding. So this configuration. So what matters is I'll show you what matters first, though. Here, let's see if I can frickin' find it. I want to show you where it's getting. Here it is. So when you instantiate, so here you go, my model object, right? I haven't trained it. I'm instantiating it. Okay? Can you see the model I'm using, the transformers model?
Yeah.
Tell me what is it? Yeah. And a Roberta base. So you actually can use, for this multi-label classification, I could use any transformers model I want as long as it has a classification task, a final layer like you were talking about, top layer. Mm-hmm. So I'm just using Roberta base right now just because that's the one they use in the examples. But my feeling, for simple transformers, my feeling is that to get more complicated, it might matter which model I use, right?
So that class multi-label classification model from simple transformers, that gives you that extra layer that gives you classification?
Yes. And simple transformers take care of that because I'm not telling it which task version of Roberta base to use, right? Simple transformers grabs that because it's a multi-classification model. That's a simple transformers class right there. Mm-hmm. And when I instantiate this model, I bet if I give it some model that doesn't have, if I give it a model class like Roberta and a submodel, a model, and that doesn't have that task covered, right? Because, transformers, I don't know if they provide the Hugging Face. I don't know if they provide, multi-label classification for every single model. Do they? No, I bet they don't. There's probably some models that don't do it and can't do it, but I'm sure I'll get an error if I use the wrong one here. Right. So do you get that, Yuri? This is skipping a lot of shit, right? I mean, this is like doing a lot of stuff for you.
Okay.
I just give it the name of the model, and it gets the right version of it from Hugging Face. And you don't see here because I've instantiated it twice, but underneath here in the output, you would see that it downloads it to Colab, mm-hmm. The model. It's quick because it's Colab. But it downloads it for use. And then you have to tell it how many labels, right? And then you just give it some configurations, which I'm using up here. There's all sorts of great stuff with simple transformers because you can do early stopping, you can use your own metrics, You can evaluate during training. That's what these are. So you just instantiate a model arguments class. You see that class is multi-label classification args, right? And then I give it the arguments that I want, number of epochs, batch size, which I increased from 8 after reading the literature a bit. Anyway, so you got your args, you instantiate it, and I'm just looking at all of the arguments by using the dictionary for the args, the model args, right? There's a lot of them. And I think you could send any arguments that the model has natively as well. And then I train the model, so I'm giving it its training set. It's a data frame, which now has, instead of IDs, it has the full text, because I joined those back in after Stratify. And I give it the evaluation set. Now this failed because I can't directly, I'm giving it some scores to use here, but I can't use those. I forgot, because you have to, multi-label returns ranked, and I have to turn them into binary. So I need to actually give F1 a function that use, this is the I'm getting too deep in this, guys. Sorry, way in the details. But this is the scikit-learn F1 score. I imported it from scikit-learn, but you can't do that. I actually need to make my own function that takes the output and turns it into a binary. If you have 10 topics, you have an array of
Oh, I see. So
classes.
do the equivalent of softmax, right? So you get basically a bunch of ranks, and then you would convert it back to like probabilities, and then the argmax of that.
No, I'm just getting, actually what I'm getting, what you get back from simple transformers from the multi-label classification is you can get back an array for each document, right? You get an array of 10, because it's 10 topics, of ranked, of float probability.
Okay, scores.
Yeah. Okay. And the problem is that at these particular metrics from Spacey won't work on that. They need binary. They need to know which is true. They need a threshold applied.
I see. Okay.
To those.
Right.
Yeah. So I just forgot about that, because I've done it before, but that's why it failed here. But anyway, then you just do your predicting and stuff. And Yuri, does that kind of give you a little more context?
Yeah.
Yeah, I mean, it's a great way to just, why not? You just go for it. It works. Push it until you're like, you find the problems, and hopefully I won't have to go directly into Hugging Face. But maybe I'll have to abandon this and do that. Who knows?
Hugging Face also has a pretty high-level API as well. It's not like you're going raw PyTorch on it or anything, right? So even if you go to Hugging Face, you'll still find a lot of abstractions. And then if you don't find what you want in Hugging Face, then you go to PyTorch, right? So.
Exactly, and that's the. I mean, sometimes it's not always good to go from the top down like that, right? But I happen to know that simple transformers. I used it before on our Kaggle tweet extraction, right? So I happen to know that it was pretty robust, and that it would be a great way to. I mean, how do I know if LSTMs are better for this problem, or if just random forests are better for such a large multi-label classification? I don't know. So right now I'm doing in the optimize versus exploit Bayesian analysis that I am. I'm exploring, and so I know that that's a great way to do an exploration without totally screwing myself. So but,
you don't invest too much effort into it.
Yeah. Well, I'll find out pretty quickly here, because initially I tried to do this with many more topics, and I was not getting good results. It was not good. So I really don't know if this is going to work for large-scale multi-label classification. So anyway, all right. Anything else for this?
No, thank you.
Sure, you're welcome. All right. So I have a sort of a small question. So if you have, this is not an NLP question. It's a ranking question, like a custom kind of rules-based ranking. So we have like accounts, which are companies, and accounts are like companies have multiple people reading our content, right? So we know that certain accounts are interested in certain topical areas, right? We also know from that different prospects or people from that company are the most active. But the point is, we want to rank accounts. We rank accounts and prospects now, and we're kind of in the process of maybe redoing the way we do it a little bit. I'm not directly involved in it, but it would be things like this company, so this account or this company has been reading about these topics, but it's been doing so increasingly over the last month, right? And it's been doing so on this type of content as opposed to this type, like white papers, or on these kind of web pages of this content type, or also it's been mostly like the CTO that's been doing the research, right? So this is not an NLP problem. It's just you have data, an entity, like in terms of database terms, like a person, this is a prospect, or an account, which is a company, and you have just different attributes for it, right? Database attributes, values, columns. And you want to somehow munge all that together into a rank score of whether it's a list of accounts or a list of prospects. And is there some sort of framework or way of doing that other than just sort of hacking at it, like adding points, doing things like that?
I just wanted to quickly ask you, so you don't want to look at change in the behavior, but you just want to rank as what happened this month, and then if your ranking change, you'll know about it. So you mentioned as an example, they started reading more. You really don't look. You're not looking for like sudden change of behavior. You just want to like create a rank on how much they were reading, and then if it goes up, that you could make. Yeah.
Well, no. I think that we could include that, but if you think of that as in, you could think of an arrow like increase. Let's just take that and turn it into an attribute, right? This person's readings on this topic have increased over this last. Let's just take a week as a time, right? So it's on the rise. So yes, we care about change of behavior, but the problem I'm talking about now is just simply whatever. It's just an attribute of that data, right? So yes, okay, an account is on the rise, or an account has all of a sudden, on decline, or whatever the behavior change is, it turns into an attribute. So it's just a matter of mixing and matching attributes to come up with a rank, between 0 and 1, so you can rank them. Or maybe it's not 0 to 1, maybe it's just an unbounded one. I just don't know if you guys know some standard ways of kind of handling that kind of mixing and matching.
Do you need to, rank them in a certain way? I mean, is there like, given the data, there is, okay, so is this like a supervised problem, right? So do you have an idea of what the rank should be given the data, right? And then that's how you change the weights of each of these features.
Oh, so this is super stupid simple at this point. Okay. I know what you're getting at. That would be great. It's not machine learning.
Okay.
I'm just talking about, most enterprises probably deal with a lot of this stuff where they'll just like say 10 points if they were read something yesterday, and then 3 points if they did this, and then you add up the points, and then I don't know how you and then you just rank them by those points. You know what I mean? There's got to be a much more mathematical way of weighting, the attribute into a 0 to 1 or into whatever. It's a simple.
Right. Well, if you had, if you had a ranking to begin with, then you could back calculate the points and then apply the points going forward, right? So, yeah. But I mean, otherwise, just gut feel, right? I mean, it's what the CEO says or the marketing guy says, right? So it's
yeah. I mean, I'm just wondering how you combine it all, but okay. I'm just thinking about that. Yeah, we definitely don't have anything like ideal rank. Okay, guys, I'm going to open it up, and either you guys have anything you want to share? Yuri, what you been up to?
Not,
right.
Not much to show this week. One thing is they have NVIDIA conference going on. I don't know if you guys have been following it. It's a free NVIDIA GTC conference, and it's open, and it has like it's very different format from NeurIPS. It's more companies kind of centered, but a lot of researchers that are there. So they don't give you like latest and greatest. It's more solutions, kind of what the companies have, what they're doing.
We discussed it at the beginning of the ML pipelines call yesterday, very briefly. I think that's when we discussed it, and it was interesting because. Yeah, go ahead.
No, go ahead. I missed the.
Were you there?
No, I couldn't go yesterday. I hope they recorded it.
Yeah, I'm probably not going to continue to go. I mean, to me, the most interesting thing from my point of view is seeing how Wenchang does his engineering, because it's very different than how I do it. So I've learned a bunch just by watching that. Although he thinks the way he does it is the right way to do it, I think he's overcomplicated for the data science people there. But it's very competent. It's very interesting to see how he does his engineering. But yeah, so what we mentioned about it was, pipelines, right? Because of course they have their whole pipeline, right? They have a complete pipeline, which allows you to use different, different machine learning packages and things. And also it came up was, I also heard that, I heard on a podcast too that, they're actually going after they're going after Intel's market for what, AMD? Is that what's the new CPU technology? Not that new, but
yeah, I've seen that. Again, I just saw it in the news. They're gonna have their own CPU.
Yeah, and it's the newer architecture, from the last 10 years or whatever. The one that ARM. Yes. They're going to go to ARM. What they say is I don't understand exactly all that, but they're creating an ARM CPU. I don't know what the market is, but it's going to compete with Intel. My brother-in-law works at Intel in Hillsboro, in Oregon here. And those guys they're doing great, but my God, they've ceded a lot of the market. So, but anyway, that's all. So that I'm hearing they have a great product, the Rapids product. You guys, right? I mean, if you're doing Spark type of enterprisey kind of large scale processing, it definitely is it really competes well with the Spark frameworks that are out there, I think. But anyway, anything else, Yuri, from that conference?
No, there was one. I think that video was shared. The self-supervised energy-based method from Jan LeCun. That was pretty. I started watching it. I haven't finished watching it yet, but it's almost like on any topic you can find. So if you, what I started doing, I just did a search, and I was interested in agriculture, and they had like one of our competitors. They always present, but that was like a nice way of like seeing what they were doing. So it's a very, very big conference, and it's really like application based, not sort of latest science. And I don't know if you saw this. So somebody started posting the weekly AI news on the general channel, and I think it's sponsored by Ray Summit. So they're gonna have Ray Summit in June. So that may be interesting.
That's another great tool. There's so many of these great platforms out there.
Deep Learning Weekly, right?
Yeah. Yeah, I haven't read it. Like I just clicked on it and then I saw that it was sponsored by Ray Summit, and then started following the links.
And how about the satellite segmentation? Any more thoughts on that?
Yeah, we're preparing to do more. Yeah, I don't know. I may show something at some point, but right now it's we don't have anything good to show. So
I heard a podcast about. I think this is outside of your wheelhouse, but it made me think about you because it was doing machine learning and AI with soil. So profiling soil, the microbes.
that's interesting.
Yeah, I think they were doing a lot of sequencing, right? And then they were using that for prediction, and they had all sorts of ideas of where they would go with that, and pretty cool. Yeah.
Which podcast was that?
Shit, I can't remember. Sometimes those podcasts, I listen to so many, I don't think I'll ever find it again. But I'll try to look it up for you real quickly after the call, okay? So I thought to send it to you, but I'm like, I don't know if it'll be interesting. So.
Yeah, we tend not to, there are companies that go in basically kind of try to apply AI in different parts of agriculture. We tend not to do that. We only do this large commercial, commerce basically of agriculture. So that's why satellites are important, because you can try to predict what's being grown and what the yield is going to be, but at very large scale, not at field level.
Yeah. So. This is kind of like a micro to your macro.
But we have people who actually know a lot about soil, because again, it's important for us because there are a lot of companies that sell stuff like fertilizers. So that's we're trying to build different models, what demand is going to be basically.
Very cool.
Oh yeah, I mean agriculture traditionally has suffered more than almost any industry to vicissitudes or whatever of weather and market. You know what I mean? Because you plant and then you just get screwed one way or the other, or you make a ton of money. You never know what's going to happen with all that. It's a mess. So you guys just sort of trying to help stabilize the market in a way, make it more predictable.
Yeah, that was the initial kind of premise on why I built this company. So because if you can predict really well, then people can invest.
Yep. Well, talking about exciting and interesting things like that soil stuff, I did listen to one of the podcasts. It was really cool. There's an app I downloaded. I haven't used it yet. It's by Microsoft. The fuck's the name of it? But it's what you do. It basically uses. It describes what's around you. Okay. It's really initially for blind people. It's called Seeing AI, and it allows the user supposedly to choose the mode, but it could tell you what's in the room. If there's a person in the room. It'll also tell you if you're trying to take a picture of something with your phone, like a document or something. It'll tell you if you're close to it, or you know what I mean. It'll help you by beeping to get to where you want to be. It's he uses all these different modes of different types of machine learning, and it sounds kind of amazing actually. So I got kind of excited about that one. I downloaded it. I give it a try, but I could see all kinds of applications for it, right, other than just for blind folks. And he did talk about how a lot of technological innovation historically has come out of trying to solve problems for people with disabilities.
Right.
So it kind of made sense. It was interesting. Anyway. Okay. How about you, Suji? What's on your mind these days? What are you exploring and trying to bring to fruition these days?
Yeah, well, it's been I haven't done much. Yesterday, so I tried to use reuse basically Spark with a Stanford core. So that's I was looking at somebody else's code and trying to just do that. Right? So that's all I did. The other things.
I just looked.
Yeah. Go ahead.
I was just looking at Stanford Core, maybe because you brought it up. I can't remember, but I took a look at it. and it's sort of like a Python. It's a Python version of
the stanza you're talking about.
Yeah, because they've always been so Java centric. It was a problem in the past a little bit for me, but it looks promising.
The Python client is basically, it creates a web server on the fly and then queries Stanford through HTTP and then gives you the results in Python. So it looks
nice. Very spacey. It's like low-level spacey kind of stuff as well. Like spacey's really low, is NLP from Stanford kind of stuff, really. But yeah, that's right. It did all the dependency tree parsing and the
Stanford Core actually has better dependency parsing. They are the gold standard, basically. Spacey, so that was another thing I don't know if I talked about this. So we were trying to, so Spacey is like approximately 4 times faster, 4 to 8 times faster than Stanford Core. And so we create, annotations against the full entire science directory, entire scopus. So those take a long time. So far, we have been looking at SCNLP for our dependency parsers and for the other parsers that they have, the constituency parsers as well, but mainly dependency parsers for things like relation extraction. And it turns out that doing this is impractical for the size of data that we have. And it takes like days to finish. So the idea was to now switch over to Spacey and see if it's good enough for our purposes. I did some work on that, and basically it involved, first manually comparing outputs of SCNLP and Spacey. Sorry, not manually, automatically. And then looking at the ones where they did not match, or they don't match most of the time. But looking at them, side by side, like doing the graphs, drawing the graphs and looking at them side by side. So the thing I have come to the conclusion is that the graphs are different, definitely. But in the cases at least the cases I saw, and I looked at around 20 of them, which is not much. It takes a long time to basically compare the 2 sentences and the dependency charts. In the sentences I saw, Spacey was actually better at predicting relationships than SCNLP. Right, so that's kind of an odd conclusion to have, but it could be my data set. The general feel is that SCNLP is like the gold standard. I mean,
but that makes sense to me, and that's a great way to judge it, by the relationships that come out. And the reason is because it makes sense for 2 reasons. One, shit happens the opposite of what you expect with machine learning and with data. Enough, right, that you can accept it. And second of all, a lot of times just simplifying produces better results, actually.
Well, some of them are accidental too. Well, some of them are accidental. So one of the things I noticed that Spacey really sucks when it comes to tokenization, right? So SCNLP is like head and shoulders above them. So it does like brackets, it spreads them out and all. But in a lot of times, the Spacey tokenization may be incorrect, but it leads to the right answer. Because of the tokenization makes it so complex, the sentence structure and the dependency parse structure, it becomes like, sometimes it leads to wrong results because of the complexity. So there's that.
So what is it, SCNLP?
Stanford Core NLP.
Oh, the Stanford Core NLP, okay.
So I just call it SCNLP because it's faster to write and talk about.
Of course, yeah. Oh, the core. So that's the core NLP.
Yes.
Or is that what you're talking about?
No, Stanford Core NLP. So SCNLP.
Sorry. So let me ask something. In terms of speed of processing all of your stuff, were you able to explore distributed computing?
Ultimately, this is going to be on a distributed platform. And so we have done the Stanford Core on a small subsets of our corpus, like the CC BY corpus, right? So CC BY is a Creative Commons, and it's, it's a public license. Basically, the stuff that is CC BY can be basically given to the public free of cost. So that's a smaller subset. It's about 20% of our data, I think. Now it's going up. Used to be around 10-15%. Now it's gone to about 20%. So we can run the Stanford Core dependency parsers on that, and within a nice time frame, whatever is acceptable to them. I don't know exactly what it is, but it is not acceptable for the entire Science Direct or the entire Scopus, right? So,
but you don't see distributed computing as a way to.
Oh yes.
Maybe it's slow, but you could still do it.
No, that's the point. Like we would do distributed computing anyway, but
so
whoever it is,
it's going to be too slow. You think it's going to be even too slow with distributed computing? Really? Right. Isn't it massively parallel? I mean,
yeah, you can infinitely parallelize it, but I think there is also cost implications, right?
So, yeah, of course.
There is an upper bound to the
Yeah, it would be stupid not to compare, because now let me just ask you, what is your gut on how much faster Spacey is than
it's between 4 to 8 times faster.
Really?
Yeah.
That's a lot.
Yeah.
That counts.
And that's Spacey 3?
Spacey 3, yes.
I like Spacey 3 because it actually is doing entity extraction correctly for orgs. I'm quite happy.
So that was one of the things I was doing. It's kind of boring. Yep. I mean, not you basically look at 2 dependency charts and try to figure out what's the difference between them.
I don't know how you could do that. I don't know how you could do that visually. I mean, that's not easy.
It's possible. It's not well. It's not hard, but it's boring, right? I mean, it's taxing basically mentally for a human to look at it. Essentially, what you do is you look at the sentence, you see what the sense, what it's trying to say, and you want the main subject, predicate, object, right? The main predicate to be, the center of your dependency chart, right? And then you kind of work outwards and see if, so you could have multiple clauses in a sentence, right? So you could have, how many of those roots are they, are each of those clauses being correctly identified by the roots, right? It can have multiple kind of roots from the main thing, right? So it starts off, you will have only one real root, and then you have subroots of those, right? So yeah, so it's kind of hard to explain, but it's possible, but it's kind of, you don't want to do it.
Well, it's probably good for you to do something boring once in a while.
Yeah.
Because everything you do is like cutting edge and learning new, doing stuff. Right. You're addicted to it, like I am, of course. I'm so spoiled. I like it pissed off. Yeah. Although I actually do love digging hardcore into the results and the details of the data, because I like to feel very confident about what I'm getting or not getting and what's going on. A lot of times that helps you really understand what's happening. So I do get addicted to that, but it's good for us to do boring things once in a while.
So, but then I learned, on the programming side, I learned how to use core NLP and convert it to display-C input, right? So the idea was that I would use. Oh, okay. Yeah, so one of the things I learned here, mainly because I was trying to draw the graphs. Can you hear me? We can't hear you.
Yeah, I can hear you.
That was a simple solution. I was muted. So, landlines aren't supposed to drop. This is like a hard line, right? And it just drops like you're on the phone too long, buddy. I'm dropping you. Sorry about that.
Yeah, it's all right. You're using a cell phone though, so it doesn't have the the guarantees a landline has, right? So that's also true. So in any case, so the idea was that, I was able to use Displacy for both the Stanford core as well as Spacey. So that was something new I learned, that you can do that.
Say that again? Oh, that's right. No, I saw that. You can use Stanford core in Spacey?
Oh, no. So
as well, or it's the other way around. I think you could do it both ways.
This is only for the Displacy tool, right? So you can, Displacy is tightly connected to the rest of Spacey, obviously, but you can also send in input in a particular form that Displacy can use to render, non-Spacey input, right? So that's something I learned there. So I use that. You can say, I think custom equals true or something, and it requires a particular format. I'll find out and send it out. It's actually quite interesting. So that was one. And the other thing I did was mainly for, this is to evaluate the SciSpacey UMLS entity linker using the med mentions data as labels. So that's the other one. That so far it's not very impressive. I mean, well, I actually so talking of impressive, I found a nice evaluation criteria from Basis, and this is I thought it was quite a nice criteria for evaluating named entities in a very principled way. So I can share the link if I can find it.
So you're talking about entity linking?
Yes.
Or the whole entity identification problem in general. Well, I remember your entity linking project for sure. Yeah.
Right. So entity linking actually says, okay, find me the best one. But in this case, we are using it more like an NER, where the entities are concepts in UMLS. Right. So it's mainly, the reason I call it entity linking is basically it's a two-step process for SciSpacey. So first it identifies candidates, and then it looks up those candidates in the UMLS taxonomy, right? So rather than the typical NER where, the NER learns to look for entities of specific types within the text, right? So it's like a one-step process for NERs and two-step process for NELs. So that's
you come, but your output is an entity type.
The output, the way I'm using it, yes. For NEL, the output can be a ranked list of entities I found, right?
Yeah.
That matches my candidate. But here I'm just picking up the top and putting it there. And so it's really like an NER, yes. Yeah.
Okay.
So that was, but I like the evaluation criteria. I'll share it if I can find it. I think I should have it somewhere. And so those are the two things I did, basically. That's all I did. Let me find
Well, you said nothing when we started.
Well, yeah.
Not as much as you normally do.
Right, yeah.
But, yeah. Okay. We'll wait to see if you can find that. So I've got nothing. I'm just going to keep at work focusing on multi-label when I can. But there's all these things going into production that are taking a lot of my time. So that's. I'll be lucky to get, another. I hope each one of these meetings I have another little multi-label update. But we'll see.
Oh wait, ignore that. There is actually, this is not the right one. They have a PDF version which has what I actually wanted to show. So if you look at...
I'm opening up the white,
Yeah. If you look at Appendix B of the document, the PDF, that's where, this is the evaluation criteria I used. It calculates precision recall and F1, just like everybody else. But in the inputs to those values are very nice here. So there is correct and incorrect and partial, missing, and spurious. Right. So those are the things that was like really good. And the precision and recall formulas are a little different too. So that's.
So I'm sorry. Where is that? I'm looking. I don't see the.
Look at Appendix B. Of
no. I found Appendix B. The details of scoring NLP results. And so go ahead and say that again while you like it. Yeah. I heard part of it.
So typically we think of precision and recall in terms of false positive, true positive, and that sort of thing, right? And it's a pretty high level thing. But here, what they have done is the correct one is kind of trivial. I mean, they just have to match the label and the judgment. And but incorrect here is like the entity bounds match, but the tag does not match, right? Then there is partial where the tag matches, but the entity bounds do not match, right? And there's missing where the entity is completely missed, and there is spurious where a new entity has been created when none existed, right? And so they use all these to calculate your precision and recall. So it's a little different formula. It probably ultimately boils down to the same thing, but so I use this one instead. So one of the things that I was kind of stuck on, because all I got was basically spans initially, right? So I got the sentence and it says, okay, I found this span, this span, this span, and and it corresponded to these UMLs. That was the label, and that's how even the NEL or NER also gives me the results, right? So I basically converted both down to this bio format, IOB format, so that I could use this kind of scoring. So
yeah,
that was,
this makes perfect sense. I mean, it's so practical that I have the same problem with multi-label classification with a large taxonomy. Is I would look at I'd get with my Word2Vec thing that's going into production, which I'm using for classification, right? It's weird, but I was looking at the precision, and it was like 60%, right? That sounds like shit.
Mm-hmm.
Or even worse. But when I actually looked at the results, I'm like, no, this is actually a pretty good topic. Just because the manual classifier chose this one, the classifier chose the broader one, or chose a narrower one, a child, right, within the taxonomy.
Yeah, exactly. Right.
Or it chose really tightly related, right? So that's almost analogous to what you have there. I need a formula where I use the context of the taxonomy, right? To, maybe you get different. Maybe you could have different rings. Like I'd like to see the hard coded precision and recall, but on the other hand, I'd like to be able to move that bullseye out. So we'll include children and parents, and include related. And so I like to see the score for each one of those, and then maybe a formula that takes that all into account. Maybe. Yeah, that would be my ideal. I'm not sure how you do all that, but this gives me a bit of a model for that, because you see their equations.
You can see them side by side, right? Yeah, that's. I think that's a good point. I mean, that's something my manager said as well. He said it doesn't really. So my results were like 0.56, 0.55, that range, right? So so he said it doesn't actually mean much, because the MedMentions data labels are not really good either, right? So maybe you should look at the errors and see if your results are better than the labels.
You know what I had to do? I literally, because I don't have a metric for this, even at 50% precision, it was pretty good. And I had to literally get a spreadsheet, and put a couple columns in there, a column and with a note, and go through 100 individual. I told you about the boring obsessive stuff that matters. Is literally, because you really need to do that. Otherwise, it's all bullshit. Your model's bullshit. Your metrics are bullshit. The bottom line is you got to look at like 50 to 100 of those things, and intuitively say, well, this is good or not, right? Ideally, I could turn that intuition into a metric like they've done there, right, with the entity stuff, and that'll help speed up that process, but you still end up having to look at it all at the end. So, and you don't hear that anywhere. All of the benchmarking, all the metrics. I'm like, you know, there with multi-label classification, I haven't figured out a bunch of stuff because there's also different like Hamming score, and there's other things that try to do that, but I don't still don't think they represent what I'm talking about. I have to work my way through all of that. So, but because you have to have an intuitive understanding of what they're doing with those. So, anyway, great. That's very analogous. I like that for those entity scores. I'll have to look further at that. So. All right, guys. Anything else? So I leave for LA. I leave for Los Angeles on Friday, Saturday, 2-day drive, and then I'll be in LA for a while with my wife there, who's working on a show. So my venue will change a little bit.
Oh, cool.
That's all my excitement in my life. That, and I'm fully vaccinated now.
Nice. Okay.
Pretty exciting. Yeah. I got like on the extra dose list, you know, with my local clinic. I saw on Facebook they were doing it, and it must be 5 weeks ago now. I got the Pfizer, but I was like, they called me, and I'm like, I'm coming. They're all waiting for me. It takes me like half an hour to get there. So I got that, and then I got my second one. On Friday, I'll be 2 weeks out from my second one. The world still sucks, though, but at least I'm vaccinated. I don't have to worry about myself as much. So, how about yourself, Sujit? You all set?
I get the second one day after tomorrow.
Excellent. Good. And how about yourself, Yuri?
Oh yeah. I got the second one 2 weeks ago. But, I did mine in PA, but I live in New York, so I'm trying to figure out. Like actually, I was just trying to figure out because in New York they already started this green passport app.
But it's tricky.
Where you can, so like, but PA doesn't do that, so I may have to carry around with a white paper everywhere that they give you.
Yeah, you should. Take a picture of that thing in case you lose it. You never know.
Yeah, where you did first thing.
For their piano, they get all the new piano.
All right, guys. We'll talk next week. Thank you.
Thank you.
All right. Take it easy. Bye.